let's look at this kinematics question, which also involves some calculus and some key concepts which you have to know on kinematics. So it's a very simple question. A particle moves along the x-axis according to the equation x equals 2 plus 3t minus t squared, where x is in meters and t is in seconds. At t equals 3 seconds, now you have to take this same point to say at t is in 3 seconds. So we already know that the time must be at 3 seconds. Find the position of the particle and the velocity of the particle and the acceleration of the particle. If there is something we need to take note of is that position of a particle is just x. So x is the position of a particle. So we will have to plug in the t 3 and O places where we have t. So we substitute t there, we substitute 3 where there is t, and so let's do that to find the position of a particle. You remember it is in meters, so we'll also have to include the units. So our main equation is 2 minus, so a pen here, 2 minus 3t, and it's 2 plus 3t minus t squared. Okay, and what we need to know here is that this is x, so this is x, and so x will be equal to, now we can substitute what's in here. You have to forgive me on my handwriting, it's very good, that's why I, so t is 3 seconds, so you have to substitute 3 there, minus, now minus what, minus 3 squared, minus 3 squared. So what's that? We have x equals, that's 2 plus 9 minus 3 squared is 9, which is x equals 2 meters. So um, the distance was just 2 meters. It is 2 meters. 2 meters. So this was the position of the particle. Now let's move on to question B. Question B tells us that find the velocity of the particle. So let's find the velocity of the particle. So remember we have given that this is x, and this is time at 3 seconds. We already know that this is our x and this is time. X stands for position. Now, one thing you have to understand is that velocity, since they asked us for a velocity, we have to say velocity equals the change in position over a change in time. Okay? Now, the change in position is the same as the x. This is the same as the x dt, which means that the velocity of the particle is just differentiating the position with time. Okay, this can also be denoted as x dot. So whenever you see something as x dot, it means that you are taking the first derivative with respect to time, the first derivative of position, which is x, with respect to time. So we need to take the first derivative of this function which we are given. Okay, now in case you don't know how to take derivatives, this video will also be give a chance for you to understand how to take derivatives in an easiest way possible. So the x Okay, let me, okay, the x dt must be equal to, now you have to take note that the derivative of a constant, okay, the derivative of a constant is always 0. So derivative of a constant is 0. So the x dt, we can say of 2, alright, equals 0. Okay, now we can move on to 3t. So the x dt of 3t, now what will this be equal to? Of course, we have to understand something here. Alright, there's something that we need to understand. And taking the derivative of 3t means removing the t. Why do I say so? When taking the derivative, you get the power, you multiply with the coefficient. So since here the power is 1, so you say 1 multiplied by 3 um, times t, then the power is 1 minus 1. Okay, then you subtract the power with 1. So to take the derivative, you just bring the power down, you multiply with the coefficient, then you subtract 1 from the power. What's 1 times 3? That's 3. And then t to the power 0, that's what? That's equal to 3. So the derivative of this is 3. Okay, I think I've told you how you can take the derivative. Now you know. So you can try to pause the video and take the derivative of that's a negative number. Of course, it might be a little bit tricky, but it's okay. So dx dt over negative t squared, what would that be equal to? It's just waiting for you to understand that. Okay, what would that be equal to? You can pause the video. Alright, I think you paused the video and now you've tried on your own. Let's do it. So we said you drop the power, you multiply with the coefficient, which is negative 1, you multiply with t, 2 minus 1, the power minus 1. So that's 2, that's negative 2, negative 2t. So which is negative 2t. Alright? So now since we have this one here, we have this one here, and this one here, we can put them together. Okay? Let's now put them together. Just give me a minute, a second, or 3 or 2 seconds just to delay this. I need to remove this out of here. Okay, I'm done deleting. Let's now see. So now our velocity dx, which is dx dt, equals to 0 plus 3t plus 3. Sorry, it was supposed to be plus 3 minus what? Minus 2t. Okay, so you can ignore the 0 and just put 3 minus 2t, and then if we plug back, you substitute t where we 3 where we have t, we have something like 3 minus 2 multiplied by 3, which is 3 minus 6, which is equal to negative um negative uh 3 meters per second. So negative 3 meters per second. Now this isn't in the question what I'm gonna talk about next. So let me just write this negative 3 meters per second somewhere nice so that you can see. For those who might not even know how to write meters per second, don't worry, that was just a joke. Negative 3 meters per second. Okay, so here is our velocity. Okay, now there's one key concept which you have to take note of, and that's how we deal with how velocity is related to to position. Now I'm gonna tell you to say the derivative of a part of a function is the reverse of the integral. Okay, so since v is the x dt, then what would you think x will be? The position of a particle will be what? The integral of velocity with respect to time. Okay, and this is one of the key concepts that we need to take note of. Okay, okay, now let's move on to question C. Actually, this was pretty long. This was pretty long. Okay, question C now. Now we need to find the acceleration of the particle. So the acceleration of the particle will be acceleration. We know that acceleration is just a change in velocity with time, right? And change in velocity with time, we said it is dx dt. So which means that we are going to take the second derivative for acceleration. Um, Maybe if you don't just believe me, let's try to write the x dt while we have position, while we have velocity, and write over dt. Isn't this the same thing as the second integral of that over this? This is one and the same thing, right? Yeah, this is one and the same thing. So that's just the second derivative of position with respect to time, which can also be acceleration equals x dot dot. So just two dots, x dot dot. Okay, now we can take another derivative of that. Now since we took the first derivative, we know that v is already we know that v is without wasting much time, we know that v is it 3 minus 2t. So we are going to take another derivative, v equals 3 minus 2t. Now you can take the derivative of this part first. We said the derivative of a constant is 0. After taking the derivative of this, which I already taught, you have negative 2, where the t will disappear. This is now after taking the derivative of velocity with time, you have something like this. So this is dv dt, which is equal to acceleration. Okay, which is equal to acceleration. So the acceleration of a particle of this particle was a was negative 2 meters per second squared. Okay, so it's meters per second squared, or you can write it as m meters second squared. This and this, all these things are just one and the same thing. Alright, thank you for watching. If you like this content, you can subscribe, share, and like. Thank you. See you in the next video.